Please introduce yourself and describe your role at Nearmap.
My name is Jeff Saunders. I'm a solution product manager for our commercial business at Nearmap. Our commercial team is focused on supporting organizations across the built environment and technology environments, usually including AEC firms, solar and property related organizations, and other mapping and technology firms across North America and Australia.
There are a lot of definitions out there, but how would you describe a digital twin?
A digital twin leverages artificial intelligence, Internet of Things, and virtual and augmented reality in conjunction with digital models of real-world assets, systems, or processes. They can come in many forms and can help visualize and understand an environment and an asset in its environment.
So what are the benefits of digital twins?
So the value of a digital twin is that it can be used across every phase of an asset's life cycle. It can provide context for design and permitting. It can help to manage progress and compliance during construction, and it can monitor and predict behavior throughout the operations and maintenance phase of an asset's life cycle. I think that, just to summarize that too, by creating a digital twin, customers have the ability to really begin to ask what if questions that help to drive and make decisions for the future of how that object and asset will act or interact with the world around it. That also helps people to test ideas out before they actually put the dollars in to construct it or to modify it or retrofit it.
What are some of the best ways to build a data foundation for a digital twin?
So I'm going to talk a little bit about Nearmap here, but as a company, we inherently look to allow our customers to see and shape the livable world at Nearmap. We've worked with a number of customers and partners to build digital twin models, but usually at the core of building a digital twin, there's a lot of data required to build that foundation. At Nearmap, we capture aerial imagery with proprietary cameras, and we develop highly accurate, high-resolution imagery and spatial data, and turn that into 3D models that can seamlessly provide the foundation for a digital twin with timely and accurate data. That data includes high-resolution imagery, and then the output from that capture and processing provides 3D meshes, point clouds, digital elevation, and terrain models, and then high-value AI-based geospatial features that are extracted from that information. And perhaps maybe the greatest value from Nearmap is also helping to provide this data at a massive scale that can accommodate nearly any project, and it's continuously updated so that information can continue to evolve as the environment changes.
Is the data foundation an overlooked element of digital twins?
Not necessarily. I wouldn't say overlooked, but because it requires a lot of input data, and a lot of the tools out there that are used to create digital twins assume certain data inputs, it's sometimes overlooked in the sense that the level of effort to create and compile and aggregate all of that information is not always the first thing that people think about when they're considering building a digital twin. And that's really where a lot of the content that Nearmap is able to provide can be extremely beneficial to building and supporting the construction of that digital twin foundation.
What are some common misconceptions of digital twins?
I think one misconception could be that the digital twin can only take one form, and that it really has one form that can then be used for a number of purposes. I think in reality, digital twins can take on a number of different forms depending on the types of questions and what if scenarios that organizations are trying to answer or trying to solve. So by thinking of what the end goal or what the question is that's trying to be solved and resolved through a digital twin process, it's really important that that's considered first to identify what details, what information is really needed to answer the questions in the end from that digital twin.
Can you cite some examples of effective digital twins that relied on aerial imagery? What are some common use cases?
Let me start with some common use cases. So a number of our customers today are looking at digital twins as a way on the AEC side, AEC service provider side, to propose, win, conceptualize, and plan new infrastructure projects. And they do that by helping stakeholders visualize the existing conditions and even immersing them in the digital world to allow them to experience projects before moving forward with design and construction. Some other use cases, really looking at understanding and coordinating asset management projects at airports or campuses, where they are continually looking to grow, expand, and retrofit existing facilities. We've seen telco providers build digital twins in order to enhance some of their design concepts and planning for 5G networks as they're looking at line of sight capabilities. We know that cities and private-public partnership organizations are looking to better understand urban mobility and how the future of cities and urban environments can benefit by assessing shared ride, autonomous vehicles, and public transit alternatives, and how that will play out in those environments. And this provides, again, a way to experience before building or test what-if scenarios. We've also seen it used for reviewing logistics for large events and event planning, as well as public safety and emergency management planning, and to coordinate construction logistics and planning exercises. So those are a handful of use cases where digital twins have been really useful for some of our customers.
How can Nearmap help develop digital twins, from foundational data to the lifetime maintenance?
So Nearmap's foundational data, the high resolution imagery and the 3D mesh point clouds, digital elevation models, and feature extraction through AI can provide that core foundational information for building a digital twin. One of our, as we look at the different tools, whether they're from our partners, Esri or Autodesk, Bentley and others, as we look at how we can provide, the beginnings, the foundational data for that, our 3D mesh, or even the ability to grow a 3D model from our AI information and terrain information. Both of those provide the key underpinnings for a foundational the foundation of a digital twin. And the fact that information is flown frequently 2 to 3 times a year in most urban and suburban areas within North America and Australia provides a way to continuously evolve and update that model. Now, within those other tools, those third-party tools like an Esri or Autodesk set of tools, you can bring our information in and then overlay it or augment it with additional context, such as BIM models or other planned 3D models that might provide additional context.
What advice would you provide to those looking to develop their own digital twins?
Probably a few pieces of advice. One, make sure you're sourcing the data or the content to provide the context and foundation in your digital twin with your end goal in mind. Obviously, accuracy and quality of data is important, but some questions can be asked with less detailed data, and other questions need to be answered with more and more detailed information. But context is critical. So it's important not to just look at a digital twin for just the asset that you're looking at, but how it fits into the context of the rest of the environment. I think it's also important to keep track of the data sources and in essence the metadata of where that information came from. So as changes happen in the real world, that information can also be updated in the digital realm as you continue to build and evolve your digital twin and continue to ask new questions of that twin. I think there's maybe two other points or sets of points that I wanted to make. One is that as you look at building a digital twin or the foundations of a digital twin, it's important to look at your building blocks, starting with your terrain and basic ground level information. And that's something that Nearmap provides through our DTM, digital terrain model, and digital elevation model products, to then look at how to incorporate current buildings and structures in the area of interest. And again, that can come through a 3D mesh or from some of the AI related data that Nearmap provides to help you grow those buildings and those structures. And then last but not least, to look at how and build out the current infrastructure, including transportation networks and utility networks, that may help to address and influence some of your decisions and how you ask some of your questions within your digital twin. The benefits of a digital twin include improved monitoring, concept testing, risk reduction, and return on investment. And that latter is really especially important when, as we're continue to see margins being squeezed and input prices are changing. So material costs are rising, labor shortages continue, and supply chain delays remain persistent. And all these issues really support the increasing value of building digital twins at the beginning and throughout the life cycle of your assets.